Yeah, I've never been in Thessaloniki before. It's a lovely city, and I'm glad that you're willing to have me here. Um, just out of curiosity, how many people here have sort of come to the conclusion, the perception that quick and dirty is bad? Show of hands. Yeah, about a third of the room. Everybody else is too hungover to admit it. When we look at some of the quotes that we've seen in industry, Edgar Dijkstra, right, one of the founding fathers of computer science. 10 years from now, when you are doing something quick and dirty, you suddenly visualize that I'm looking over your shoulders. Okay, dude's been dead for 20 years. So if he's looking over your shoulders while you're doing this, we already have bad problems. But if you see him over your shoulders and think Dijkstra would not have liked this, that's good enough. He's not a fan of quick and dirty. Martin Fowler, you guys know who that is, right? Yeah. Doing things the quick and dirty way sets us up with technical debt, similar to financial debt. That debt incurs interest payments, which come in the form of the extra effort we have to do in future development because of the quick and dirty design choice. This doesn't sound good so far. We choose to continue paying the interest, or we can pay down the principal by refactoring the quick and dirty design. Although it costs to pay down the principal, we gain by reduced interest payments in the future. This was sort of the origin of the whole notion of the concept of technical debt, was when Fowler made this consideration. He doesn't seem like a fan of the quick and dirty approach. You probably don't know Foote and Yoder. They were a pair of authors in the patterns community for quite a while. They created a pattern language that was affectionately known as the Big Ball of Mud. It was one of the first, what we now sort of refer to as anti-patterns pattern languages, in which they basically said, we don't want these, spaghetti, big ball of mud, etc. Throwaway code is quick and dirty code that was intended to be used only once and then discarded. However, such code often takes on a life of its own despite casual structure and poor non-existent documentation. By the way, how many of you have ever been on a project that had poor or non-existent documentation? Now the hands are up. Yeah, everybody's like, oh yeah, that was me. Yeah, it works. Why fix it? That sounds like a very Greek attitude, right? Why fix shower? It rains, right? You just go outside, it rains, you're all good. When a related problem arises, quickest way to address it might be to expediently modify this working code. Let's just hack it. Let's just do a quick little thing, right? One line. We got a global variable that whether or not we should actually be writing to the file or not. Let's just modify that global, do our little hack, and then we'll modify it back to where it was supposed to be. This way we get it done quickly and the boss is happy, right? Because they want their fix quickly, right? Right. Not a big fan. Over time, a simple throwaway program begets a big ball of mud. So it's bad. We're done. Thank you for coming to my keynote. Except, the guys with the signs are like, wait, there's still time left. What do I do? Except it's not always that simple. We don't always seem to agree that quick and dirty is bad. And I'm not referring to the software industry, I'm referring to other folks that often have different perspective. If you pull up your favorite search engine and you search for quick and dirty, you get a variety of interesting responses. You frequently will see the quick and dirty guide to ... which is intended as a fairly quick introduction, a tutorial, your first steps. It would not be completely out of character, for example, for you to go to a new programming language. Perhaps you're interested in Scala, perhaps you're interested in Ballerina, perhaps you're interested in something else, Ren or Flix or something like that. And you go look for that quick and dirty guide to give you a sense as to what this programming language is, does, how it looks at the world, what are its first-class constructs, etc. We frequently look for the quick and dirty guide to something. We often have managers, executives, who will talk about, give me a 1 or 2 page executive summary. In some companies I've been at, that's referred to as a quick and dirty. Yes, somebody wants to think about how we should enter into a new market or build a new project. Here's the quick and dirty on it. Typically a 1 or 2 pager that kind of describes what it is, what it's supposed to do, right? Amazon has done this for a while. They actually now refer to them as reverse press releases. But it's the same basic idea. Give me a very succinct, short summation of what this thing is, what it's supposed to do. Quick and dirty is also found in the Urban Dictionary. I'm not going to tell you what it means, because that's where all the bad words live. Okay? It's time for us to re-examine the concept of quick and dirty. Because if there are so many other places, so many other areas, domains, intellectual pursuits that don't consider quick and dirty to be bad, or at least don't consider it to be all bad, it's time for us as computer scientists and developers and engineers to rethink our perspective. Because when the entire world is going that way and we continue to stubbornly remain here, it may be that we have good reasons, but we should examine what those reasons are and make sure they're still legit. Most people, when we start to break this down, most people are okay with the word quick. Is there anyone here who actually prefers it when something is done slower rather than faster? Not seeing, there's one guy back there. Yeah, really? You take your car into the shop and you're happy if they take 3 days instead of 2? Yeah, he's like, I just wanted you to pick on me. I just wanted attention, right? It's okay. There's a support group for you, man. Somebody give that man a hug. Anyway, most of the time we are comfortable with quick. Most of the time we are comfortable with something going fairly fast as opposed to slow. Certainly your boss is happier with faster rather than slower. It's the dirty part that we typically take issue with. It's the dirty part that leads to that concept of technical debt. It's the fact that the concern is that we didn't think about it clearly enough. We just chose whatever happened to be handy, and that's the dirty, and therefore that's where that debt is going to come and play in, and blah, 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 blah. The dirty is the part that we really, really worry about, right? Again, Fowler talks about this, right? Because of the quick and dirty design choice, in other words, when we were starting to work on this application, we chose to just use SQLite. Right? It's a lovely little standalone database. It can hold up to about, 2, 3, 4 gigs of data, maybe a little bit more, depends on your file system. It will work certainly for smaller applications, but it's deployed everywhere. We can actually compile SQLite to run inside of a browser, for crying out loud. Yeah, let's just use that, because every language on the planet knows how to talk to a SQLite database. So yeah, we'll just grab that, right? As a matter of fact, most of the time, developers can feel when projects are starting to make some of these dirty decisions, right? They can start to sense that, yeah, we just kind of grabbed whatever things were off the shelf available to us, we slap it together, we go. It's harder sometimes to explain it, but you can just feel it. It's like, dirty, blah, bad. But Fowler goes on to talk a little bit more about technical debt. That quote isn't the full measure. People have made a considered decision to adopt a design strategy that isn't sustainable in the longer term, but yields a short-term benefit. See, this is the funny thing about debt, is that in many cases, debt can be, in fact, a good thing. Debt can help you out of particular obstacles. Debt can help you accomplish something that you might not otherwise be able to accomplish. For example, you walk into the Apple store and you see the new MacBook 2022 sitting there on a pedestal under a shaft of light. Oh. They're always under a shaft of light. Have you ever noticed that? It's like Apple is trying to set you up. Like I think actually they would get better sales if you had to like hack your way through a jungle to get to the store, right? So you walk in, you see the MacBook Pro there, and you're a developer, and of course you've got to get like the biggest model. You want the 16-inch screen, right? Maybe you have like an old MacBook 2013 that only has 8 gigs of memory, and the new MacBook has like 64. And maybe this one you've got currently has only got a ½ gigabyte of drive space, and this one has like 8, or terabyte, I mean, of drive space. This one has 8, right? And it's got M1 processor, and the battery life will go on for years or whatever else. And then you walk over to, the salesperson and you say, how much for that MacBook? And they say, oh, it's only like 8,000 euro. And you're like, oh. And I have a credit card. Because there's 2 ways you can approach this, right? One way is to go back home and talk to your spouse and say, honey, I want to save money up to buy the new MacBook Pro 16 with blah, 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 blah. And she says, okay, cool, we can put 250 euro off to the side every month, right? And you'll be able to buy the MacBook after you have accumulated all that money, sometime after you're dead. Or you pull out your credit card and you put that credit card on the counter and you say, I'll take one. And then when you get home, your wife kills you, of course. But no, seriously, honey, this is an investment. I'm putting 8,000 euro into an investment because this will be faster. It'll let me do more things, let me take some gigs on the side, do a little freelance work. I'll be able to increase my rate. By the way, I'm not the only one who's done this, right? Nobody's going to help me out here? Nobody. Yeah, one guy's like, yeah, that was me. Yeah, right? Because what you're doing is you're using that debt, you're using that credit as a way to get you past a particular obstacle. It's a way to get you the thing that you need in order to be able to do other things down the road. The point is that the debt yields value sooner, but, and a very important but, needs to be paid off as soon as possible. The debt metaphor reminds us about the choices we can make with design flaws. So the useful distinction isn't between debt or non-debt, but between prudent and reckless debt, and between deliberate and inadvertent debt. This right here is the whole crux. Most of the time when we start talking about technical debt, especially when we start talking about it to managers and so forth, there is always that underlying assumption that technical debt, bad. But that's not true. In the same way that financial debt isn't bad. As a matter of fact, in many cases, it's good. It's a question of what did we do with this debt now that we have it? And it's a question of what decisions did we make in order to incur this debt, and what did we use this debt to pay for? Fowler's 2-axis quad leads us to 4 scenarios that are worth considering. The first is the one that most of us recognize intuitively, the deliberate, reckless debt. The project where the boss comes up to you and says, hey, the guys in marketing, they want a little prototype. They want a website. They want a thing. And, they just want to know if it can be done. And they want to know if you can get it done by the end of the week. And you look at your watch and it's Monday. And you think, with a little React, with a SQLite database, maybe we'll just use some really straightforward logic. Yeah, I could probably whip something together by Friday. And so you do. You pull out React, maybe you pull out Bootstrap or Tailwind or one of those other CSS frameworks, and you throw something together, right? You just comment out large swaths of stuff that you don't need. You just hack a few things in there to give you the functionality that you do need. And on Friday, you present this. Now, before I continue, did you know that developers are actually Jedi. Sadly, we haven't figured out lightsabers yet, but developers are in tune with the Force. And you remember from Star Wars, the original Star Wars, when the planet Alderaan was destroyed, right? Billions of voices crying out into the void, right? Developers can feel that. Because when a developer comes into one of these meetings with one of these prototypes, we start to get little reverberations through the Force. And then the developer shows this prototype to the marketing guys. And the marketing guys go, "Oh, that's amazing." And you're thinking, yeah, this is a good idea, but in the back of your mind, and those of you who've been through this is like a horror novel playing out in front of you because you know what's coming next. You're like an action hero in slow mode. Ship it, they say. Take this project and ship it. Put it into production. It's everything we need. And you're like, shit. Because we're not done yet with the pain. Because what happens next is your boss comes over to you and says, "Oh, that was a great job, great job, great job. Now, here are the other additional features they want implemented on this project." And you're like, "But we need to go." No. They love what you've done so far. There's no time to rewrite anything. Just add these other things. You're so good a developer. You did this whole thing in 5 days. The rest of that team over there, they're lazy. It took them like 6 months to put a project together. You did it in 5 days. You're amazing. And you're like, shit. So you like try to change teams. And the boss says, "Oh, no. No, this is a mission critical project and you're the only one who knows this code. We need you to stay on this team." And so you quit the company and fly to Europe in a desperate attempt to get away from everybody. And then just before your presentation, you get a text message from somebody saying, "Hey, I found your name in the comments for this like project over here. Were you the one who worked on that?" And you're like, "No." That is the kind of debt that we're all afraid of. That is the deliberate, reckless debt. We deliberately chose to take all the shortcuts we could in order to get this thing out on time. We don't have time for design, for architecture, for any of this other thinking about the project going forward. Now remember, there's 3 other elements on this grid, this quad. The inadvertent reckless debt. This is literally we incurred technical debt because we didn't know any better. And frankly, one of the things, I know Thessaloniki is a university town. I actually happen to teach for the University of Washington in Seattle. I teach the college students there, the undergraduates. I teach them mobile development. And I have discovered, and you'll have to tell me if it's true here, I've discovered something interesting about college students. They're all idiots. Not deliberately. I'm not saying they're stupid. They just don't know what they don't know. Right? Any of you ever worked directly with a college graduate on your team, new developer on your team, right? How much you have to teach them. I mean, they know the programming language, they know the database, they took a class. But all of the other things that go along with the art and science of software development, they just don't know. I give my students a 2 to 3 week group project to try to expose them to some of those things. And it's amazing to me, for example, when they get ready to build their mobile application and they want to make an API call back to a database or back to a service, they scatter those calls all across the code because it didn't occur to them to actually put them in one class so they got it in one place. The whole notion of a repository pattern just doesn't occur to them. They just don't know. And ideally, this is where we as more senior folks inside the industry can kind of take them off to the side and say, "Hey kid, that's dumb, don't do that. And here are the reasons why." And hopefully, if they're smart, they'll go, "Oh, I get it now." But that comes later. When they're writing the code, they inadvertently make bad decisions because they just don't know any better. Now, they could have perhaps sat down, done some research, come to you for questions. They could have done a bunch of things, but they're college students, and they desperately want to prove to you that they're not stupid. And so they sort of recklessly charge into this, not knowing the mistakes they're going to make. On the other axis, we have the deliberate, prudent debt. This is the MacBook Pro case, where you deliberately put some debt onto your credit card because having this new MacBook Pro will unlock so many new opportunities for you as an individual, as a developer, potentially as somebody who could do some freelance work, whatever. However you want to justify it to your spouse, that's up to you. But it's a deliberate attempt to take a prudent amount of debt in order to unlock things for you. Perhaps you are really, really interested in going to work for one of the FANG companies, maybe perhaps Microsoft over here on the sponsor floor. Well, okay, Microsoft, obviously you're going to need a certain amount of familiarity with Windows. Don't get me wrong, a lot of Macintosh laptops running around on the Microsoft campus. But you're certainly going to want to show Microsoft that you're familiar with their products and services. So even though you've been an Apple fanboy for the last 10 years, you decide that you want to go purchase a Windows laptop and start experimenting with the Windows terminal to understand how that experience is different from doing so with a MacBook. Again, that's an investment. That is a prudent use of deliberately decided debt to be able to get you to where you want to go, which is to say that job at Microsoft. The last is, in some cases, the kind of technical debt we don't really recognize until it's too late, which is the inadvertent prudent debt. That is to say, we look back at the project and realize that with the benefit of hindsight, we should have done it a different way. We should have taken a different path. We should have perhaps chosen a different technology, but it was one of those things that we couldn't necessarily know that at the time we made some of these decisions. There are a lot of companies who have run into this sort of inadvertent prudent debt. And in many cases, trying to pay that debt off is extraordinarily problematic. For example, COBOL. A couple of giggles coming from the crowd. COBOL. What, those people were idiots, right? Because that was a language written back in the 60s, right? And would it surprise you to know that COBOL continues to cash your paycheck today? COBOL was a huge investment, particularly by the financial companies. And don't get me wrong, every single year, some hotshot developer walks up to their VP boss in a financial technology company and they say, hey boss, we really, really, really should start to replace some of the legacy COBOL stuff that we have. And the VP, who's been through this conversation a few times, says, okay, sure, what do you have in mind? Well, there's this really, really cool programming language called Elixir. And it will totally make things completely different. And maybe if the boss is really feeling generous, we can go through and create some sort of experiment to see how fast Elixir. But now we have to figure out how we're going to do all the migration, all the databases, all the code. And we have to figure out how to make the code bug for bug compatible. I use that phrase deliberately because with a lot of these legacy systems, there are bugs that we work around via process. Yeah, it turns out that when we actually add these two things of this particular type at the same time, that creates this little inconsistency which we correct manually and keep going. All these different workarounds that are now enshrined in the company's processes are also part of the equation that we have to try to correct for and fix. This is the inadvertent prudent debt. Now, there's a number of interesting decisions that sort of fall within this spectrum. And so, for example, when I started my career, we were writing a lot of C++ code. And then Java came along, and a lot of companies turned around and said, oh, let's go adopt Java. Let's go write new projects in Java and so forth. And at that point, it could seem like C++ was a bad choice, but Java hadn't existed at the time when we made that decision. So one of the things when we go back and look at some of these decisions and sort of decide for ourselves what is debt and what isn't, you always have to have in the back of your mind, what was the context of the situation at the time they made that decision? Frequently, I will run across new developers who look at code from 10 or 20 years ago and say, who wrote this mess? And I will remind them that most developers actually try to make the best decision possible given the information they have at the time they have it. Doesn't mean it's always going to be perfect, doesn't mean it's always going to be right, but they did the best they could because in some cases we didn't know what else was going to come. This leads to some questions that we want to have floating around inside of our head as we start thinking about this deliberate discussion of technical debt. For any given scenario, for any given choice, where we can choose a quick and dirty path versus something that's longer and cleaner, if we take this debt, will it in fact be a prudent debt? Will this be something that we can actually pay off in time? And if so, how will we pay it off? This is usually where many companies fall down. They often stand up and say, oh, yeah, no, we get it. We're taking shortcuts, and we'll pay it off somewhere in the future. There are a lot of people in the United States who declare bankruptcy every year because they just say to themselves, oh, we'll pay it off in the future. And the nice thing about the future is always the future. Because today is today, and the future is still yet to come until one day the debt collectors show up and repossess your house, your boat, whatever else. Be careful, obviously, of leaving the debt in place for too long. Those interest payments, that metaphor definitely applies. But we have to think about it prudently at the time we take the debt. Because in some cases, when the boss comes to you and says, hey, we have an opportunity. You work perhaps for a sporting goods company. And let's assume that the Greece football team is doing very, very well in the World Cup. And we have an opportunity. There's lots of people who are excited and are looking to buy Greek player jerseys and so forth. And so we want to provide opportunities. We want to provide some new deals, some new discounts. We need to modify the website, and we need to do it before Saturday when they play in the semifinals against whomever. When they play in the quarterfinals, the finals, we need to make these changes because, let me be very, very clear, nobody is going to move the World Cup just so that you can make sure your website ships on time. Throwaway code is quick and dirty code that was intended to be used only once. There are a lot of times when we as developers are asked to be brought in on some hopefully temporary projects. Particularly if, for example, your company acquires another company, or if your company is acquired by another company, or perhaps you enter a new partnership. And over there is a database. And it's a database filled with interesting and useful data, but it's in a schema that you just don't care for. And we know that we want to migrate that data over to our database because our schema is perfect. Right? And so we need to write some kind of migration tool to pull the data out of that database and put it into our database so that we can, what? Are we going to delete that database? This is an important question. Are we ever going to delete that database? If I write a really, really nasty, ugly Ruby script that sucks all that data out and puts it into our database, what do we do with the old database? What happens to it going forward? Because if, for whatever reason, there are other processes, other programs, other websites that are continuing to put data into that old database, this Ruby script is not a used only once and then discarded kind of scenario. And in that case, we probably want to think a little bit more carefully about how we're going to maintain this, how this migration is going to occur, et cetera, et cetera. This is the fate of most of those one-off database migration scripts, is your boss says, yeah, we need to grab all that data, go to it, and then you say, okay, cool, here's a quick and dirty, I just slammed it out overnight. Cool, we'll run that once every 24 hours until they delete that database, and 10 years later, that database is still chugging away, and now you've got this random Ruby script being hosted from this cron job up in the cloud, and you've long since left the company, and nobody quite knows whether, even when they delete that database, they're not quite sure what to do with this script. Is it necessary? Can we nuke it? And if that script fails, or if that database changes its schema, or if our database changes our schema, who's going to maintain that? Because you wrote it because it was Ruby, and you'd heard that Ruby was a really, really powerful scripting language. This is the kind of prudent decision-making you have to undertake when we start thinking about these one-and-done kinds of programs, applications, scripts, fixes, whatever you want to call it. There's another interesting tangent to all of this, though. What if we are all operating under a tremendous misassumption about what it is we're trying to do? Another question for the audience. How many of you are working on a software, program, system, architecture, what have you, that has been around for longer than, say, 10 years? Show of hands. It looks like maybe a quarter of the room, maybe. 15, keep your hands up. Put them down if it's not longer than 15 years. 20 years? 30 years? I can keep going. 40, do I hear 40? 50. COBOL? 60 years. Going on 70 years. When I was writing C++ code, we often looked at all of that COBOL code and said, yeah, we should replace that. And yet, 30 years later, that COBOL code continues, and I'm absolutely convinced all the C++ code I ever wrote in the early stages of my career has long since been deleted. What if, despite our developer-stated intentions to try to build something that will live through the ages, to try to build some of these wonderful artifacts, these wonderful architectures that will stand the test of time. It's really, really fun saying this, standing here in Greece, right? I come from a country that didn't exist 300 years ago. Y'all have bathrooms that are older than that. No, seriously, the guide was pointing out that was a bathhouse and that was a bathhouse. What if our real goal isn't to create software that will stand for the ages? What if our goal is to actually try to solve an immediate problem that may or may not exist some period of time from now? The whole smart house thing is a perfect example. My wife was talking with a friend of hers, and this friend, they just moved into a new home. And the previous owners had installed a bunch of these smart gadgets so you could control the lights and the thermostat and the garage door, all from your mobile phone. Except when the homeowners, the old homeowners, when they had left, they obviously discontinued their account with all of those services. And so the new homeowners moved in, and after a couple of days, they discovered there was a weird beeping coming from somewhere in their house. And they determined that it was one of these sensors, systems, whatever, that was trying to communicate to the server, and it wasn't able to, so it was letting the humans know that it wasn't able to communicate back home. So the new homers called the company, and they said, hey, company, I want to figure out how to turn off this beeping. And the company said, oh, yeah, this is because it's trying to communicate with the server, blah, blah, blah. Well, can you service this? And they said, no, we don't have a contract with you, so we're not going to come out and do anything for you. And the new homers said, fine. What if we take a new contract with you? And they said, oh, no, we're not going to do that because we're actually deprecating that service and we're going to release something new in about a year. Okay, great, the march of progress, but meanwhile, these poor homeowners have a system that is signaling an error condition because it made the assumption that it would be around forever. What if that's not the case? How do we deal with the deprecation of systems? Maybe the time we invest in trying to build this amazing, beautiful architecture is a complete waste of time because, in fact, all we're really trying to do with this first version is get into the market. Living in Seattle as I do, there are a lot of startups. And one of the things that startups frequently focus on is time to market. How quickly can I get a product into my customers' hands so that I can at least prove that this idea is a viable one? We toss around the phrase minimum viable product. And the idea, lean startup and all of that, the idea is if you want to create a business around something, get your first customer. Then get your 10th customer. Then get your 100th customer. Just get something in their hands so that they can start to use it and start building some of that momentum. And you know what? We will probably, this is again the era of prudent debt. We will probably need to throw that away at some point once we've got our 1,000th or 10,000th or 100,000th or millionth customer. Does anybody here believe that Netflix still runs the same code that they did when they were a tiny startup in Silicon Valley, whose business model was to ship DVDs to and from your house? Some of us are old enough to remember those days, back when Netflix was basically Blockbuster through the mail. And somewhere in the back, there's some young kid turning to his colleague, 20 years old, "What's Blockbuster?" I actually made that reference to one of my college classes, and they all just went. Systems are no longer targeted to be long-lived. If a given software system gives us 10 years of life, it's actually pretty good. Now, there's always going to be exceptions to that rule, but generally speaking, in a 10-year cycle of life, there's often pressures to replace it. Remember when Java hit about its 10th, 15th anniversary, right at that time, Ruby on Rails was really, really popular. And everybody was saying, oh, yeah, forget that Java crap. You should just rewrite it all in Ruby on Rails. It'll be so much faster, so much easier. It's a dynamic language, for crying out loud. I remember when Java first came out, being a C++ developer. And the boss said, hey, yeah, we've got all this code in C++. We need to rewrite that code in Java because C++ is dead, long live Java. And then I remember hearing the same thing about Java to be replaced by .NET and .NET to be replaced by Ruby. And I guess today everything is supposed to be JavaScript, right? Is there something else coming that I'm not aware of? I don't know. WebAssembly, it'll rule the world. The other thing, though, is that Agile actually exacerbates this particular problem. Because what is the whole point of Agile? 2-week sprints, iterations, give the customer some value, ship at every release, at the end of every sprint. There's a variety of different things because Agile is an attempt to basically give us something working as quickly as possible and then cycle through this as quickly as possible. So when you start working on an Agile project, almost by definition, you don't know what you're building. Now, this is a response to the basic fact that most of the time, we don't know what we're building. Not even the people who want it know what they want. Common rule of thumb is that every time you show working software to your customer, your client, whoever it is that's paying you to build this, they will look at it and it will cause them to realize that they want something slightly different. This is good, but is often the response you get from a lot of these Agile release day delivery meetings and so forth. There was a time when we told people, let's sit down and figure out precisely what it is we want to build. We're going to take 6 months to do this, yes, but we know exactly what it is we want to build at that point. We will go build it. At least that was the theory. And it turns out that, yeah, we didn't really know. I'm not saying Agile is bad and Waterfall is better. No. I would never say that. But it's the realization that Agile is asking us to make best guesses, which means that we're going to be wrong sometimes. And by the way, here's an interesting caveat. If you have never actually thrown away one sprint's worth of work because it wasn't exactly what the customer wanted, you may be doing Agile wrong. There are people in the audience who are like, throw code away? Are you nuts? My boss would kill me. Because in many cases, companies are more interested in activity than they are actual progress. They want to be able to show that we did what we were asked to do, not necessarily that we actually provided any real value to our customer. That's a deep discussion for a different day. Inc., which is one of those highfalutin financial economic magazines, they did an interesting article, The Importance of Quick and Dirty. When we work on something, we pay careful attention to the details, take the time to polish every little thing until it's just right. As a result, 37 Signals. Familiar with these guys? This is where David Hannemeyer Hansen works. These are the guys who make Basecamp. They're pretty well respected as a software development company. As a result, 37 Signals is known for a focus on quality, and we take that reputation very seriously. It turns out that that's a problem. We recently began exploring an idea for a new software product. For 6 weeks, we sketched out a bunch of ideas. We finally felt we had a great idea. All of us were excited and working hard, but a week later, we had almost nothing to show for our effort. Nearly 2 months had passed since we had set out to test the idea, and we still had no idea if it would work. See, part of what happens in the business world is that you need to test your hypotheses. I have this brilliant idea that I came up while I was in Krakow speaking at a conference there right before I came here. I want to create a business that will offer mortgages for people who want to build pet houses. The fact that none of you are laughing at that tells me it might actually be successful here in Greece. Because, I mean, seriously, you've got all these technology people with more money than God, and they like their pets because they can't find a spouse because they're so busy working on code all the time. But whatever. So to take out a loan to build a ridiculously sumptuous doghouse for their pet schnauzer, this sounds great. Oops, there we go. I guess these guys don't like the idea. They're like, nope, that's my idea. Cut his mic. So now, going back to the Agile principles, lean startup, I need to get my first customer. I need to get my 10th customer. I need to get my 100th customer. The first one might be pretty easy, right? I'll just walk over to Patrick Close, who I know loves his doggy. And I'll say, Patrick Close, I'm willing to give you like 10,000 euro to build just the most amazing doghouse. And he goes, okay. 10,000 euro, not going to say no to that. Right? And we write out a little something on a piece of paper and we exchange that and he starts making mortgage payments. Cool, I got my first customer, but my 10th customer, my 100th customer, where am I going to find them? How am I going to grow my business? I don't want to wait 2 years while I'm trying to build this fintech solution. I need to get something fairly quickly to see whether this actually has legs beyond the one guy who's like, yeah, if I don't actually take Ted's idea, he might not show up to do the keynote. Sure, I'd love to do it, right? That's the problem with friends and family, right? Sometimes they'll actually support you even when it's the dumbest idea ever. Obsessing about quality too early in the creative process prevents a lot of good ideas from taking shape. This might actually be a good idea, but if I can't actually get people to use this, then, we're not going to go anywhere. It will be a huge waste of money if we build this ridiculously scalable and powerful website. As businesses grow, all sorts of things that were once done on the fly. We sat in a Greek cafe, we wrote it down on a little sheet of paper, that's our contract. That's not going to work. We're going to need to figure out how to create more long-lasting processes and better databases and so on and so forth. Doubts, deadlines, resource planning, all of this stuff is essential, but only later on. Fretting about such matters at the outset only gets in the way. Quick and dirty, so that we can get some results, so we can see whether or not we keep going with this. The minimum viable product. Get yourself that first customer, 10th customer, 100th customer. It might not even be software, by the way. What I would described earlier, us sitting in a cafe, that was just two slightly deluded old men with a piece of paper between them and way more money than anybody should have if we're thinking about building pet dog houses. Set a hypothesis, build something, prove or disprove the hypothesis. This is what a prototype is supposed to be. If you are asked, by the way, at your place of business to examine a new technology, boss comes to you and says, hey, we want to talk about Flutter. Flutter seems pretty interesting. Google supports it. Idea of a single source base to be able to write both iOS and Android applications seems like a really, really good idea. Should we use it? Build us a prototype of our current mobile app. Let me tell you something right now. If you choose to do the easiest parts of your existing mobile app, let's display some data, let's display a button, let's move between screens. I'm here to tell you any technology can do that, even COBOL. I have never tried to use COBOL to build a mobile app. I still know it will work because that is the easiest thing in the world to do. But getting your mobile app to talk to your legacy system, which happens to use Corba instead of HTTP because you built this 30 years ago, can Flutter do that? That's the thing you need to figure out as part of your prototype. The whole point of a prototype is to prove or disprove a hypothesis. It helps, by the way, to say out loud what your hypothesis is. All that scientific method crap that you learned in biology class way back in grade school turns out to be useful, not because you need to know what the guts of a frog looks like, but because that process of set a hypothesis, examine the evidence, prove whether or not it works, that's the actual useful part. It's that iteration that becomes useful when we start doing this over and over and over again. Look at Agile. Look at the Agile Manifesto. Responding to change over following a plan. Working software is the primary measure of progress. Being able to show something to somebody so that they can say, yes, this is what I want, or not. Simplicity, maximizing the amount of work not done, is essential. Much of the Agile Manifesto is built around a single concept, which is to say, feedback. Get me feedback as to what it is that I'm doing so I can know whether I'm on the right path, whether I want to continue working on this, whether we want to change directions, whether in fact this market is valid. It's a constant quest for feedback. An iterative process is one that makes progress through successive refinement. Take a first cut at a system knowing it's incomplete or weak. Start to sound familiar. It's all about feedback, iterative refinement. Each iteration, the software is improved, and so on and so on and so on. It's not just software, though, that this concept of iteration and refinement and constant improvement and so forth comes into play. Anybody here ever heard of OODA? O-O-D-A? Oh, good, I get to tell you about it. There's a gentleman by the name of John Boyd. Not anymore, he died a number of years ago, but John Boyd was known as 60-Second Boyd. He was a fighter pilot for the United States Air Force. He was called 60-Second Boyd because within 60 seconds of you and he going into air combat, he could get on your six. In other words, behind you in a position to shoot you down. Now, I don't know if that was true or not, but lots of people who were there said that yes, that was the case. That Boyd was an excellent fighter pilot who had an intuitive understanding of air combat. And one of the things that Boyd did is he started to dive a little bit more philosophically and analytically into how he was, in fact, a good fighter pilot. And he coined this acronym, the OODA, OODA, Observe, Orient, Decide, Act loop. The idea is that when two pilots are facing each other in the skies, they go through this loop. They observe, look at the data. Where is my opponent? What is my altitude? What is my airspeed? What does it look like theirs is? Gather some data, and then look at what the available options are. Do I engage? Do I disengage? Because if I'm not in a great position, it may be better to actually disengage and let somebody else engage with this one, or in fact, just turn tail and go home because there's 5 of them and 1 of me, and I've got information I need to get back, or whatever. You look at all the options that are available to you, and then you make a decision. This is what I'm going to do, and then you enact that decision. I'm going to climb, gain some more altitude, I'm going to make a sharp left turn, whatever it is. Now, the interesting thing is, yeah, this sounds very much like the Agile loop. But Boyd was not as interested in the loop as he was in the timing of the loop. The fundamental, unavoidable, all-pervasive presence of uncertainty is the starting point. I'm flying. I know there's a bad guy out there somewhere. I don't know where he is. I don't know what they're going to do. I don't know what I'm facing. You slowly refine that sense of uncertainty. Has anybody here ever started a software project not being entirely clear as to what they were going to build? Matter of fact, I think it's fairly safe to say, have you ever known exactly what you were going to build and then built that? We most frequently start from uncertainty. Must be able to form mental concepts of observed reality, change those concepts as reality itself appears to change. As we see things develop, adjust our thinking, change our mental models, et cetera, et cetera, et cetera. By the way, that link will take you to an expanded picture of Boyd's loop. He actually has several different stages, steps, et cetera, through that 4-step process. But Boyd's stated aim was not just, hey, we're in a loop, go. The idea was, as a fighter pilot, if you could get inside your opponent's loop. This is the same thing in business. If you work for a company that has a close rival, and you take, say, 12 months to, in fact, implement a feature, implement a new feature on your website, provide a new website, provide new functionality, et cetera, et cetera, and your opposition takes 6 months to do so, they're inside your loop, and they will win. Every single time. Because even if you come out with the most amazing new feature ever, it will take them only 6 months to duplicate it or duplicate something similar to it. And now you've lost your competitive advantage. But if they're able to release something new, it will take you 12 months to duplicate that, during which time they can do 2 more things. And now you're 24 months behind the curve. The whole goal of the OODA loop was to figure out how to get inside the other guys, the other pilots, the other companies' cycle. If you think about it, this is part of the reason why we do care about how long it takes to build something in software. Because if I can build something in, say, a week and it takes you 2 weeks, then in fact, I can get those releases out. People can examine my software and say, yeah, this is what I want, or no, we'll move on. It's not the loop itself we want to focus on, but the tempo and speed with which the loop executes. Which means we need feedback, and we need it as quick as possible. And we can't do that unless we've got something running. I see startups overthinking simple problems, adding too much structure too early, trying to get formal too soon. Startups should embrace their scrappiness, not rush to toss it aside. This, by the way, is, I think, what happens to large companies after, when a startup becomes a large company, they lose that sense of scrappiness. They lose that sense of, we're trying to just get something out the door. This is the thing, by the way, for all their flaws, this is the thing that Facebook tried very, very hard to embrace for quite a long time. Move fast and break things is their motto. Now, again, there is a place and a time for that. But there is also that place and time for doing something more formalized to make sure that we don't break too much stuff. And at a certain point, you will have delivered what the customer wanted. At which point, it is time to take your hands off the keyboard. You're done. You're finished. You delivered what they wanted. Now, it may be the prudent time to stop and re-examine the debt that you introduced, to re-examine what exactly you were supposed to accomplish, to examine whether this delivered the value, whether it validates the market feedback, whatever. But at any given point in software, there has to be a point where we say we're done, because we need that moment to stop, take stock, reflect, see whether or not the context is the same as when we started. Again, I go back to what I said earlier about Netflix. When Netflix had 1,000 customers, they had software systems that looked very different from what they have now. You need a moment where you say, that served us well then, but now it's time to do something different. How many of you still sleep in the crib that you slept in as a baby? It's exactly the same kind of thing. At a certain point, we outgrow our successes. Even if it was the world's most lovely crib, at a certain point, it just doesn't fit. So you stop, hold on to it maybe to give to your kids for your grandchildren, but then you move to something else. What does all this really mean? Quick and dirty, as we established earlier, often thought of poorly by developers. People often think, quick and dirty bad, quick and dirty bad. Stop them. One of the things I've noticed over the last, say, decade or so is there are people who are espousing the software craftsmanship movement. We're not just developers, we're craftsmen. We don't just slap stuff together. We build things for the ages. We write code that someday future generations, 2,000 years from now, as they float around in the virtual reality that we're all in, aka Matrix style, they will look at the code, the green flowing down the screen, and they will see your initials and they will say, ah, it is beautiful. And frankly, they are doing us a disservice, because when they say everything must be a work of art, they are ignoring that sometimes, rather than painting a masterpiece, you just want to paint the side of your house. Sometimes, instead of sculpting a lovely statue, you just want to create a hand-fired bowl to give to your spouse to say, look what I did in art class, which you then use as a water dish for the dog. Not everything has to be a work of art. And in many cases, it makes more sense to get it out the door in the hands of people so they can give you that all-important feedback. Don't let your ego as a craftsman steer you away from an interesting and powerful tool of approaching a particular project. Now, when do we abandon the quick and dirty? Well, I mean, some of this is pretty intuitive. Has the problem lasted longer? Does it have more angles? Are we considering keeping the system for more than 5 years? There's a whole bunch of related questions to this. I am not here to tell you that this is the only way. If there is any one thing you can know about me as a speaker, I will never tell you there is only one way to do anything. There are always a variety of competing tools. This is but one tool in your toolbox. Don't neglect it. And with that, I'm done.
Ted, thank you very much.